Well, hello, this is Dr. E, and we're going to now begin a chapter on the atom. The atom, which is the basic building block of all the material, all the matter that you see around you, everything you come in contact with, from the air you breathe, to the food and water that you drink, to the notebook computer that you're using to view this video, from your clothing to the molecules that make up your body, everything is made of atoms. Atoms are the basic building blocks. And so in this first lesson we will give an overview of the atom, and then in subsequent lessons we'll learn about all the different types of atoms, all the members of what we call the periodic table, all the elements, and how they are used then as building blocks to create everything around us. To understand the world around us, we have to first understand these building blocks. Now you'll notice that in this slide I say that matter can be thought of as stuff. Everything that you can hold in your hands, the air that you breathe, everything is matter. And this matter is made of these small building blocks. Now a way that we will represent atoms is shown on the bottom left. We will begin by simply representing these as spheres. For example, we will draw carbon as a black sphere, oxygen as a red sphere, hydrogen as a white circle, and we will show how these can be linked together to form larger molecules, such as the one shown on the bottom right, which happens to be sucrose, which is sugar, the sugar you place in your coffee or tea. And while we will draw these on the scale that we can see, actually these are on the nanoscopic scale. That is, they are extremely, extremely small. Now let's go back in history and talk about the first philosophers or scientists, if we could call them scientists at that time, who conceived of the notion of the atom. Let's go back to ancient Greece, to Lysippus and his student Democritus. Lysippus on the left and Democritus. Lysippus obviously looking more serious. Around 400 BC, they did a thought experiment. They asked the question, what if you took a small grain of sand or a grain of salt and you would cut it in half? Discard half, take the remaining half, cut that part in half, discard, cut the remaining part in half, discard, etc. That is to continue cutting a grain of sand in half, and at some point they rationalized you would approach an uncuttable particle. Uncuttable, which they called atomos, which we now of course call the atom. So they conceived that all matter must be made of these tiny, tiny components, which they called atoms. Now if you look at the drawing of Democritus on the right, you can see that he was a very jovial person. He looks like he would have fit right into the college party scene here at the university. He was called the happy philosopher, and he had some interesting quotes. He was known for his quotes. One, he said, "Nothing exists except atoms in empty space. Everything else is opinion." He also said, "Happiness resides not in possessions and not in gold. Happiness dwells in the soul." Now, while Lysippus and Democritus conceived of this smallest uncuttable particle, other philosophers took a different approach. Empedocles, Plato, Aristotle considered matter to be made of 4 root elements, which we've traditionally called earth, wind, fire, and water. And they focused on the properties of these 4 basic elemental components. That is, fire and earth they considered to have the property of being dry. Makes some sense. Water and earth they considered to have the property of being cold. Air and water they considered to have the property of being wet. And fire and air they considered to have the quality of being hot. So their notion was that all matter was made of different amounts or different ratios of these 4 basic root elements, and that gave matter its different properties of being hot, dry, cold, wet, etc. So they focused on the qualities of matter. Now later Aristotle added a 5th element, what we could call the quintessence, 5th element, called ether, which in the diagram would have been placed right in the middle. So this was the way that other Greek philosophers tried to understand the composition of matter. Now, we shouldn't think that they were unenlightened, because realize at that time that they did not have access to any of the kinds of scientific equipment that we have nowadays. They did not have lasers or super colliders or mass spectrometers. They had to search for an understanding of matter just based on their reasoning ability. So while Leucippus and Democritus gave us the concept of the atom, other philosophers, Empedocles, Plato, Aristotle, and others, considered matter to be continuous, and with the quality of matter depending upon the amounts of these four basic elements, what they called elements: earth, wind, fire, and water. And the atomic explanation for matter really was neglected for nearly 2,000 years until around the year 1800, and we'll get to that later. Over the years, additional elements were added to this scheme of earth, wind, fire, and water, and ether, because other substances were identified as being pure, and those included gold and copper and sulfur and silver, iron and mercury. Gold was thought to be the purest of elements, the ideal element. Sulfur was fascinating because it was a yellow solid that burned. Mercury was fascinating because it looked like liquid silver. But the Aristotelian concepts of earth, wind, fire, and water, plus maybe a few of these other elements, dominated our thinking until about the year 1800. Now, you may have heard about alchemy. Alchemy is sort of a philosophy, science, or a philosophical tradition that dominated medieval thinking. And alchemists, those who practiced these arts, shared a goal of trying to find the philosopher's stone. And a philosopher's stone was thought to have the qualities of being able to convert other metals into gold, which was considered to be the ideal metal. Or the philosopher's stone was thought to be the elixir of life, which of course extending life was thought to lead to perfection. Alchemists over a period of time developed a number of techniques, and I show you in this slide a drawing called the Alchemist Workshop, and that these tools led to experimental sciences that we now consider chemistry. Before talking about the elements that we now know exist today, the full complement of elements, let's first give a basic classification of matter into these categories. Matter is either a pure substance or a mixture, and it is either a solid, liquid, or a gas. The latter three we call the phases of matter. And let's talk about these for a minute. In the classification of either being a pure substance or a mixture, a pure substance may be one of the elements. We're going to talk about the periodic table of the elements. There are about 114 or so of these elements. And as shown in this slide, we have a name for all of these elements. For practical purposes, we can represent them as just a dot. Now, we will talk later about subatomic components of atoms, but we can consider these at this time to just be nanoscopic particles. A pure substance can also be a compound. Compounds are made by linking together in some type of bond two or more atoms. A simple molecule or simple compound that we experience every day is water, H2O. H2O means that there are two parts of hydrogen linked to one part of oxygen. A way we represent the structure of water is shown below. H2O with the oxygen being red and the hydrogens being these little white dots, and then showing a linkage or a bond between them. Now, matter can also be a mixture, and mixtures can be either homogeneous mixtures or heterogeneous mixtures. One way of thinking about homogeneous matter is that if you had the top half or the bottom half of that substance, it would appear to be the same. For example, if you had a bottle of cola, the top half, the bottom half would essentially be the same. A heterogeneous mixture is one in which you can relatively easily separate the components, either by filtration or just by letting the mixture stand. A classical example of this is oil and vinegar salad dressing. That you know, if you take a bottle of salad dressing and shake it up, it will momentarily be a suspension, but then if you let it stand, the oil and the aqueous layers will separate, with the oil on top and the aqueous layer on the bottom. Other examples would include things like mud, where you can fairly easily separate the components by filtration. The difference between homogeneous and heterogeneous mixtures is whether or not you can easily separate the different components Now let's talk about the phases of matter. Solid, liquids, and gases. On the left, I show the solid phase of matter as a blue cube placed within a larger container. A solid is defined as that phase of matter that has a fixed volume and it holds its shape. That is, if we put that blue cube into the larger container, it will still be that blue cube no matter which corner of the container we place it. Whereas a liquid phase of matter also has a fixed volume, but it will assume the shape of the container in which we place it. Generally, it'll assume the shape of the bottom half of the container under the influence of gravity. A gas is that phase of matter which will expand to completely fill whatever container we've placed it in. So solids, liquids, and gases, three phases of matter. Now we're going to pause, and you're going to be asked to do an exercise or answer a few questions before returning to our next lesson on the atom.